I think that's good enough. Okay, Mr. Nelson here. What up, Hazelton? Spartans. So, I'm a little under the weather, a little loopy, but we're here now, we're together. So let's learn. So far in quadratics, we have been learning, really we've been focusing on, I want colors. We've been focusing on general form, okay, or general form, which is y is equal to ax squared plus bx plus c. And then we've also learned about our standard form, or vertex form. Standard form, vertex form, okay? And that is of the shape y is equal to ax minus p squared plus q. Okay? Both have their functions, but for just a kind of an immediate usefulness, standard form helps us a lot more. Why? Well, because each of these letters, A, P, and Q, tell us something immediately about our parabola, okay? A tells us whether we're opening upwards. So if A is positive, it's a positive number, we're going to be opening upwards. If it's a negative number, we're opening downwards. If the absolute value of A, so regardless of the sign, negative or positive, if the absolute value of A is greater than 1, then we are going to be compressing. With respect to our baseline between both of these is y is equal to x squared. That's our baseline parabola, and that is a parabola that is perfectly symmetrical around the y-axis and just touches the x-axis like that. That is our baseline. This is what we're comparing everything against. So it's compressed against that. If A is the absolute value of A, so just the value of A, regardless of its sign, if it's a number that is between 1 and 0, so if it's a fraction, if A is a fraction, we're going to be expanding. Okay, so that's what we can see right off the bat with our standard form. The other thing we can see is we can find our vertex. So our vertex is going to be at PQ. And that tells us that our axis of symmetry occurs at P, or when x is equal to P. So our axis of symmetry here would be x is equal to 0. So our axis of symmetry at x is equal to P, and our max or minimum value of y is going to be y is equal to q. Okay, so in this case we would have a minimum q, or a minimum value for y of 0. We can also, from here, from our standard form, we can determine how many x-intercepts we're going to have. And how do we do that? Well, we look at the combination of A and Q. Okay? So, if A is a positive number, we know we're going to be opening up words like this. So if A is positive and Q is positive, then that tells us that we're going to be anywhere above the x-axis, which means we are going to have, so if A is greater than 0, and B and Q is greater than 0, we're going to have no x-intercepts. No x-intercepts, right? Now, in this case, if we had a negative Q and we're still opening upwards with A, well then the negative Q would bring us below the x-axis, which means we're going to cross there and there. So if A is greater than 0 but Q is smaller than 0, we are going to have 2 x-intercepts. And If a is greater than 0 and q is equal to 0, that means that we're going to just touch the x-axis like this, and we'll just have one x-intercept. In the same breath, if I have a negative a and a negative q, it's going to look like this. The negative a is pushing us down, and then the negative q brings us below 0, so we're going to have, again, no x-intercepts. So when a is smaller than 0 and q is smaller than 0. So the opposite of this. So a smaller than 0, q smaller than 0. If I have a is less than 0, I haven't looked at the camera in a while. If I have a is less than 0, so it's downwards, and then q is a number bigger than 0, so it's positive, well then we're going to be looking like this. And then again, I have two x-intercepts. So when a is less than 0, but q is greater than 0, I have two x-intercepts. And then again, if a is smaller than 0, but q is equal to 0, then I'm this case right here, where I just touch the x-axis for one x-intercept. Okay, so that is something, so number of intercepts we can figure out just from looking at our a and our q. The general form, we can't figure out the vertex just by looking at it. But what we can figure out just by looking at it is our y-intercept, which happens at y is equal to c, because y-intercept happens at x is equal to 0. So if x is equal to 0 here, that's 0 plus 0 plus c, y-intercept is equal to c. So it happens at y is equal to c. We can determine from here whether we're going to be opening up or down. If a is positive, we're opening up. If a is down, we're opening down. And then our x-intercepts we can figure out by factoring. So if we can factor this guy into some form, x plus or minus a number, x plus or minus a number, well, these will be our x-intercepts when I make y is equal to 0. So at y is equal to 0. And then if I'm so inclined, I can use my formulas. P is equal to negative b over 2a to figure out p. And q is equal to c minus a p squared. I can figure out my vertex. But this kind of gets nasty, and it's not a very clean way of doing things. So this is where completing the square comes into play. And I've been talking a while, just setting it up. But I can get from, so I'm going to erase this now, because we're going to be trying to get from general form to standard form. Okay? So, going to erase all this. So let's start with an easier one. Let's say I have y is equal to x minus 3 squared plus 2. Okay? If I want to go from standard form into vertex form, from standard form into general form, all I have to do is expand this multiplication. So to get into general form, I go y is equal to x minus 3 times x minus 3 plus 2. Y is equal to x squared minus 6x plus 9 plus 2. Y is equal to x squared minus 6x plus 11. I am now in general form. Okay? Now let's say I started with this guy over here though. It was in general form to begin and it said get me to standard form. Well, how do I do that? Well, I do that by this process called completing the square. And this is what the process looks like. Okay, first thing I do is I want to separate my constant, or my value here, that doesn't have any of the variable. So I have x squared minus 6x plus 11. I move that way up, okay? Now I look at this and I say, if this was a perfect square polynomial, So a polynomial in the form of x minus some number, or I can square it, x plus or minus some number. So say some number a, x plus or minus some number a squared. How would I be able to put this in that form? Well, to do that, I say, okay, what's negative 6 divided by 2? What are the two round numbers that add up to make 6? That can also be squared. Well, 6 divided by 2 is negative 3. And then negative 3 squared is 9. So x squared minus 6 plus 9 would make this factorable into a perfect square polynomial. But I can't just add a 9 out of nowhere. So I'm going to add a 0, and I do it kind of cheekily like this by adding plus 9 and negative 9. Now this can all stay in here, and we'll keep the 11 out here still. Now I say, okay, what is this part here in its perfect square form? Well, that part there is the same as x minus 3 squared. And then I have to add on the negative 9 that's left over there, okay? Plus 11. Now, there's nothing multiplying into this that I have to worry about, so I can write this as x minus 3 squared minus 9 plus 11. I can bring the 11 in here and add it here, which gives me x minus 3 squared plus 2. And this is my equation in standard form, which matches right there. Okay, and now this would tell me that I have a vertex at 3, negative 2. Okay, so this is opening upwards, and my minimum is going to happen at negative 2. So this also tells me, sorry, at 3 plus 2. So I'm not going to have any x-intercepts here because I'm opening upwards and I'm 2 above. So I'm not even touching the x-axis. So let's do a couple more examples of completing the square. So let's say I have y is equal to x squared plus 8x minus 5. Okay, and I say complete the square, convert this to standard form. Well, first step is to pull away the negative 5. So the negative 5 is going to move over here. And then I say, okay, how could I turn this into a perfect square trinomial? Well, 8 divided by 2 is 4. And 4 squared is 16, so this would be plus 16. And then I can't just add a plus 16, so I add 0 by adding also the negative 16. There's a net, no change here. And then I say, okay, this is the same as x plus 4 squared. If I turn this part into its factor it, and then I have the negative 16 left over, minus 5. Okay? And then there's nothing to multiply into here, so I get y is equal to x plus 4 squared minus 16 minus 5. Y is equal to x plus 4 squared minus 21. That's my final form. So my vertex here will be negative 24, negative 21. And it's opening up again, so I'm going to have a minimum. So in this case, I will have 2 x-intercepts because my minimum is far below the x-axis at negative 21. Okay. So what happens if I have a negative at the beginning? So let's say I have negative x squared plus 4x plus 7. Well, how do I treat this? Very similarly. So the first thing I do is I don't want anything in front of my x squared. So I'm going to pull out anything that's in front of my x squared. In this case, it's just a negative, aka a negative 1. So then I can do x squared plus, so negative 1 times what gives me 4x? Negative 1 times negative 4x gives me positive 4x. Plus 7. I move that 7 out. So then I get negative, y is equal to negative, and then x squared, so I can go here, I can work here actually. Negative 4x, negative 4 divided by 2 is negative 2, negative 2 squared is 4. So this becomes plus 4 minus 4. So then this is x squared minus 2, x minus 2 squared minus 4 plus 7. Okay, now to finish it off, I have to distribute this negative. So this negative has to multiply by here, and it has to multiply by here. So I get y is equal to negative x minus 2 squared, negative times negative, plus 4, and now plus 7, which gives me negative x minus 2 squared plus 11. And that's my standard form, where my vertex now is going to be at 2, 11. So I'm opening downwards because the negative here, but my vertex is at 11. So I will be crossing the x-axis and I will have two x-intercepts. Okay, now let's have one where we have a number in front of the x squared there. So let's say I have y is equal to 2x squared plus 12x minus 3. Okay, again, I don't want any number in front of my x squared. So the first thing I'm going to do is take out a 2, a positive 2. And then so I get 2x squared, 2 times what gives 12x? 6x. And then I can subtract the 3 over here. And x, so 6 divided by 2 gives me 3. 3 squared is 9. So plus 9 and then minus 9. So y is equal to 2. Well, to factor this guy, it would just be x plus 3 squared, perfect square, left with the negative 9 minus 3. The 2 distributes into here and into here. So I get y is equal to 2x plus 3 squared, 2 times negative 9 minus 18 minus 3. Y is equal to 2x plus 3 squared minus 21. So in this case, my a is 2, so it's going to be compressed but up. My q is negative, so I'm way down here, so I'm going to cross the x-axis on my way up. And then my vertex is negative 3, negative 21. Okay, one last example, combining all the different cases here. So let's do, I've got y is equal to negative 3x squared plus 12x minus 9. Okay? So, first thing, I don't want anything in front of my x squared, so I'm going to pull out negative 3. Negative 3, open it up. I have x squared. Negative 3 times what gives me 12x? Negative 3 times negative 4x gives me positive 12x. And then I can pull out this 9 over here. And so if this was a perfect square polynomial, I have negative 4 divided by 2 is equal to negative 2. Negative 2 squared is 4, so plus 4. And then make it 0 minus 4. Y is equal to negative 3. X minus 2 squared minus 4. So that takes care of this. And then I'm left with the negative 4 minus 9. Y is equal to, now I distribute this negative 3, so negative 3 times this, and negative 3 times this. So I get y is equal to negative 3 x minus 2 squared plus 12, negative 3 times negative 4 is plus 12, minus 9. This gives me a final answer of negative 3x minus 2 squared plus 3. And what does this formula tell me? Well, it tells me that my vertex is at 2, 3. And so I'm negative 3, so I'm compressed and I'm facing down. And since my Q, my max, is at positive 3, I am above the x-axis, so I'm going to hit it twice on my way down. So I have 2 x-intercepts in this case. Okay? So, in each case, we are completing the square to get from general form to standard form. Okay? Now, this comes into handy, this process, because it allows us to figure out what the maximum and minimums are, what our vertexes are. And determining vertexes helps us to do questions around optimization, where we figure out what is the ideal value for x, or for x here, so that we get a maximum or a minimum value of our y. Okay, so say we were optimizing perhaps the size of a field. What are the dimensions of the field that will maximize our area? Or knowing that every $5 increase in a ticket price results in 2 less people buying tickets, what's the ideal optimized ticket price to maximize revenue? Things like this, and we'll do some more practice of problems in the next video around optimization, but you need to know how to complete the square to be able to optimize. So thank you very much, Hazelton.